Hello, my name is Sammy Rosari, and I am in the physics class, 9 a.m. to 1 p.m. And today I'm going to be talking about static electricity. But before I do that, I'm going to be talking about atoms, because they play a major role in what happens in static electricity. Okay, this is an atom. And atoms are the smallest and most fundamental pieces of matter. Everything from you to the monitor that you're watching this on are made up of billions and billions of atoms. And as small as atoms are, they're made up of even smaller particles. At the center of every atom, there is a proton, a neutron, and spinning all the way around it are the electrons. Now, each of these particles has a very unique electrical charge. You have the protons. These are usually the ones with the positive energy. You have the electrons, the negative charges, and then you have neutrons, which have no charge whatsoever. Okay, so why is talking about all this so important? Well, actually there are certain actions that you can take that can change the actual charge of the atom, which could lead to some pretty interesting occurrences. Also, normally atoms are neutrally charged, and depending on whether or not you take away or add electrons, they could give the atom a positive charge or a negative charge. And at that point, they're no longer called atoms, they're actually called ions, and they can be either positively charged or negatively charged. Static electricity is the accumulation of an electrical charge in an object. This happens when two objects are rubbed together, much like when you rub a balloon on your hair. When they are rubbed together, some electrons jump from one object to another, and this actually changes the charge of that particular object. Now, it really depends on the actual objects to determine how strong of a charge you're going to get, but two objects that we have today that work really well together are a comb and some hair, and we will be using that in today's experiment. Okay, for today's experiments, what I'm going to be showing is the result of static electricity, or static electricity in action. So for that we have a comb and we have some hair, which are two perfectly good objects that exchange electrons and whatnot. So as she's combing her hair, I'm going to explain what is happening. The electrons from her hair are being transferred to the comb, and they're being attracted. Now, as the electrons are being transferred, her hair, some strands of her hair are actually going to be left with more positive protons than negative electrons, and as a result, you'll see, not so much today, but in certain instances, you'll see hair standing on end. This is due to the positive electrons trying to get away from each other, because they have no negative electron to be attracted to. So we have the comb, which is gathering negative charges, and as a result we're going to be using water. Oh, actually this is a good effect right here. I don't know if you can see this, but this is actually hair standing on end due to more positive protons than electrons. And to show the effects of static electricity, we're gonna hold the comb up to a small stream of water, and as you can see that it's actually moving. But we're gonna hold the comb up to a small steady stream of water to show what happens when the charge of the comb interacts with the charge of the water. So if you can go ahead and hold it up. I don't know if you can notice this, but the water is actually bending. You can put it a little closer, just a little, and move it up and down. As you can see, the water is slightly bending, and this is due, you can see that it could either be bending towards the comb or away from the comb, and that is because the comb, the electrical charge of the comb is being, or the charges of the water are being attracted to the comb. Now, as a result, and that was the experiment to show. So she's going to hold it up to the water one more time just to show you. And she's going to move it up and down, show you the wave, and that's actually the water being attracted to the negative charge. Positive protons in the water are being attracted to the negative electrons in the cone. And that is the experiment. Thank you.